finding the first term of that sequence, so I have my explicit formula. And you are told that the fifth term is 1.5 and the d value is 4.5. So I'm not going to ask anybody there. We know the d value is going to be 4.5. And a sub 1 is going to stay a sub 1 because I'm solving for it. Now, what can I plug in for? Because I got to plug in something for a subscript n and the n value, because this is the only unknown I'm going to have. All right, so let's see if we picked up what we just talked about here. And I got to get better at calling on more people here. Here we go. Anybody have 19 in here, or is that too high? Okay, here we go. Any term in the sequence. Did I give you any term in the sequence? I didn't? Is what? So that 1.5 is going to go in for a subscript n, any term in the sequence. And what's its position in the sequence? It's the fifth term, so 5 minus 1. Guys, do you see how that worked right there? Any term in the sequence, 1.5, and its place in the sequence. It's the fifth term. Can we solve this right now? Go ahead. I'll get back to you in about 30 seconds. Go ahead and solve it. Find the first term now. How high do we go up in here, by the way? Okay. Okay. First term, what was it, 7? What we were just solving for here. Or were we too busy feeding our face? Okay, I don't have the time for it today. Negative 16.5. Everybody good? Solving that. We're all right. Again, any term in the sequence, its position in there. Remember that as we go on to 7. All right. Okay, great. Trevor's opening up English language school. Good for him, humanitarian of the year. He begins with 26 students, enrolls 3 new students each week. Why is this arithmetic? Of what? 3 students every week. So that right there, this 3 new students is what value? Austin? That's the D value right there. Yep, that's my D value. 3 new students every week. Yep. He began with 26 students. What value is that going to be for me? A subscript 1. And then how many weeks will it have? 101. Okay, so how many weeks is it going to take him to, and I don't want you to go on your calculator, 26 plus 3 plus 3 plus 3 plus 3, and tell me how many times you hit plus. All right, I want to solve it using our explicit formula. And remember, we're going from 26 to 101. So you guys already told me 26 was the first term, and the D value was 3. Help me fill in as much as I can now. All right, let's get going. Okay, who's got 6? I need any term in the sequence right now other than the first term. Do you know any other term in this sequence? 101. Do we know its place in the sequence, though? No, that's what we're trying to find out right now. Is where's 101 in the sequence? Is it the 10th term? Is it the 20th term? That'll tell us how many weeks, all right, it took to get up to 101. So n minus 1 times 3. Does everyone see that? 101. That was a term in the sequence, and I'm trying to find its place, n. So go ahead and solve. And it should be whole weeks, hopefully. And how many weeks is it going to take? How many weeks? 21, how many weeks? Okay. Did you subtract 101 from 23 from 101? So it should end up being 78 equals 3n. Divide both sides by 3. It ends up being 26 weeks. Okay, everyone good? Questions before I get to this last one that we didn't get to? Okay, take a look at the patterns below. Write a formula for a sub a. Right away, which formula for a sub n? That tells me get out my explicit formula. Okay, write an equation right now for the explicit formula. So a sub n equals a sub 1. Write off the formula sheet again, guys. Write off the formula sheet. And when I write this nth for the nth term, when I write a formula for the nth term, I do not plug in for any random term, and I do not plug in for n. You are responsible for the first term and the common difference right now. And we are doing it for the shaded squares. Shaded squares right now. So take a look at term number 1 and tell me how many shaded squares are we going to have there. How many shaded squares for term number 1? Here we go, 7. How many shaded squares? Where are you looking? These shaded squares, and there's 2 of them? I'm not asking for them. I'm asking for how many shaded squares are in term number 1. 12. So that is my first term because I'm writing a formula for the number of shaded squares. 12 plus, okay, how many in the next one now? So I can find out what my common difference is. How many in the next one? 21. How many shaded squares in the next one? 16. And then if you counted it up, there should have been 20 here. So I have a common difference of what as far as the shaded squares go? Number 12? 4. Everyone see that? 4 more every time. Clean it up, please. Clean it up. Distribute the 4, add the 12. Distribute the 4, add the 12. And we end up with, just give me the, not the multiple choice, but the final answer, 7. What do we have? Yep, I know. Yep, plus 12. Okay, ready? 12 plus 4n minus 4. And I end up with questions. Okay, so here's what I'm not going to ask any questions from the assignment. I'll let you go back and try some now that hopefully you have a better understanding of how to use this formula, and I'll answer all your questions tomorrow. I don't know, maybe it's my fault that I tailored the class so I don't check the assignment, but if you're not trying some of this brand new material out, at least a couple problems, Friday's going to be rough for the unit tests, and you guys know that. And again, do you want to be in here then? Okay, if you're not going to try some of this stuff out. So tomorrow I'll ask anything from the assignment from Friday night now that you guys hopefully have a better understanding. Oh, I got one more, don't I? Okay, sorry. Arithmetic means. I didn't realize that. Okay, arithmetic means, here's what it says. I'm just going to go right to the problem. Find 3 arithmetic means between 2 and 22. So here's 2. Find 3 arithmetic means between 2 and 22, which means I'm going to add the number, the same number every time and end up at 22. But I don't want to make it a guessing game. All right. Oh, am I adding 8? Am I adding 4? Does this work? You could be there forever doing trial and error. Okay. I want to know, what do I add? What number should I add to 2? Should I add here, here to end up at 22? The same number I'm going to add every single time. So what value would it be awesome to know? What value would it be awesome to know that I could add to every term and finally get 22? The D value. That'd be great to know, because once I could find the D value, I would add it to 2. I would add it to the second term, to the third, and to the fourth. All right, so let's go ahead. We know it's arithmetic. We got an explicit formula that has the D term in it. Let's see if you guys can help me out plugging in everything except for that D value. All right, let's go. Let's roll 6. Give me any term in the sequence that's not the first. 22. Give me the first term. 12. 2 plus, remember what we talked about at the beginning of class. What is 22's position in this sequence? It is the, which term is it? 5th term, so I'm plugging in 5. 22 is the 5th term, perfect. And then I'm solving for D. Go right ahead. Yep, you're going to have to distribute. Well, actually, you don't need to distribute. Just do 5 minus 1. We're coming up with the value of D right now. 4? 5? Yep. So what am I going to do with that 5 now to find the 3 arithmetic means I need? I'm going to go back to the sequence. And what am I going to do with 2? What am I going to do with 2? Add 5. So let me get somebody here who's got 13. What's my next term? No 13 here today? No? What? Okay, that's fine. No big deal. Let's go. 15. What's that? 7. And it better work for the last one. Add 5 again, and where do I end up? 22. So I know I found the right number. So here are the 3 arithmetic means. Any questions? You're right back there, Hannah. Anything? Yes, Matt. Okay, ready? What this means, any term in the sequence. The only one, other than the first one. The only one I had was 22s in the sequence. So I plugged 22 in there. The N represents the position in the sequence of this number. So what term is number 22? It's the 1, 2, 3, 4, 5th term. So that's what that N represents.
And then how'd you get? So you don't solve it.
I did for D. Because 5 minus 1 is 4. 4D plus 2. Right? So I had 22 equals 2 plus 4D. I moved that 2 over and got 20. Divided both sides by 4, I got 5. All right. Anybody else going? Okay, so hopefully we're going to try at least a couple of those problems out. If not, at least just the 2 word problems down below there if you haven't done so already. Okay. Questions right now? Okay. Still have those graphing calculators handy. Because what we're going to do now is talk about series. Let me show you the difference between a sequence and a series right now. And again, you don't have to jot this down. I just want to show you what we're about to do. Three, 9, 15, 21. Is that sequence arithmetic? Is that sequence arithmetic? Why is it arithmetic? And how do you know? Why is that sequence arithmetic that I just wrote down? 21, why is that sequence arithmetic? 3, 9, 15, 21, 27. What makes a sequence arithmetic? Okay, so what am I adding every time? 6. So that's why it's arithmetic. Here's what we're going to do today. We're going to take this sequence and add it up. Okay, so 3 plus 9 plus 15 plus 21 plus 27. This is what's called a series, when I take the numbers of a sequence and add them up. Okay, that's what's referred to as a series. So sequence is just listing the numbers. A series is I'm going to add the numbers up. Has anybody been familiar with this symbol right here, other than being on Greek fraternity houses? Anybody? Okay. It is a mathematical symbol. All right. It is a mathematical symbol. It's a Greek letter called sigma. Okay. English translation, sum. And what do you do with sum usually? You do what with the numbers? You add them up. Okay. That's where this whole series is going to come into play. Let me tell you each part. There's 3 main parts to the sigma. The first part is this bottom number here. That is my starting value. My starting value. There's going to be a lot of plugging and chugging here. All right. At the end, there's a number on top. That is the ending value. And then there will be something plugged to the right of the sigma. That is my function that I plug into. All right. Once you do a couple, you'll get pretty familiar with it. All right. Very familiar. Okay, here we go. I'm going to take this nice and slow, all right, because it shouldn't be that complicated. All right. So here we go. Everyone see I got the 3 at the bottom, 8 on top. There's my function. Down below, that's my starting value. So I'm going to start this by plugging in 3 for k into the function. All right. So the first thing I'm going to do is take 2 times 3 plus 1. I'm going to plug 3 in. And what do you end up getting out? 7. You just figured out the first term in your sequence. How do I get the next term? Well, you just plugged in 3. Now I'm going to plug in 4. I'm going to plug in all numbers from 3 to my ending value, which in this case is 8. All right, so I just plugged in 3. Now let's plug in 4. 2 times 4 plus 1. The next term in my sequence is 9. We just plugged in 3. We just plugged in 4. What are we going to plug in next? Which number next? 5. Go ahead. 2 times 5 plus 1. So that'll be 11. What number next? 6. When do I stop plugging in numbers? When I end up plugging in the number, the ending value, 8. Yes, so go right ahead. I'm going to get scrunched here, huh? Everyone see how you're producing your sequence now. And then 2 times 7 plus 1, give me 15. 2 times 8 plus 1, 17. Yes?
Should we be able to figure out the sequence of anything by just using 3 of those?
You could, but you got to make sure you know when to stop.
Oh,
What do you mean? Like, 7, 9, 11, the next one's 13?
Yeah.
That's fine, as long as you know when to end, though. Okay? Again, this is how to produce the terms. Now, again, what did we say sigma meant? Sum. So that's what we're going to do with all the terms in the sequence. We are going to add them together, and the sum will be our final answer. Okay? So we are adding each term in the sequence together. And that ended up being 72. Okay, that is the sum of this sequence, the series. All right. Questions? One doesn't make you great. Anything right now where the numbers came from? All right, let's move on then. All right, let's look at this one now. What's my starting value for this one? So I'm going to start by plugging in 0 for n. I'm going to plug in every number in between until I plug in 4. So here we go. 2 times 3. What number do I plug in first? 0. And that'll give me 2 times 3 to the 0. Make sure you do your exponents first. Anything to the 0 is? No. 1 times 2, 2. Now what are you going to plug in? 1. And then you're going to plug in 2. Then 3. Then finally 4. And you're going to find out what all those terms are. And we're going to add them together. So go right ahead. And we get a total sum of 13. No 13 today. How about 4? Yep. Nice job. 242. And now look, now you're hopefully realizing it doesn't have to be arithmetic, because this is not an arithmetic. I'm not adding the same number every time here. All right, we can do this to any sequence whatsoever. What don't you like? What's new about 3? There's a number outside, right? Okay, 2 plus. All that means, guys, is at the end, you're going to add 2 to your sum. You're not going to add 2 to every term. All you're going to do is take your final sum at the end and add 2. That's all that means. Okay? So if you start, what number am I going to start by plugging in? 1. Okay, so 13 minus 3 times 1. And then 13 minus 3 times 2. 13 times 3 times 3. And 13 minus 3 times 4. But just remember, hey, take a look before you get cranking here. Take a look. Just remember, add 2. Okay, add 2 at the end. We don't add 2 to every term. No, no, no. All right, we just take 2 and add it to whatever our sum is at the end. And are we getting, just to get going, 24? 24? Remember, if you got 22, you got to add that 2 on at the end. Okay, so hopefully you're getting 24 at the end. Are we okay? Because I'm going to show you something different for this next one. Are we okay right now? Real quickly, let me get rid of that plus. Let's pretend I got rid of that. What do you think you're doing to your sum at the end now? Multiplying it by 2. Okay, not multiplying every term by 2, multiplying the sum by 2. All good. Okay, if you don't already, you're going to hate me now. All these that I've been making, can we understand how to do it out by hand? Because you could do it all in the calculator. Okay, your calculator has this already programmed into it. You just don't know where it is until now. Okay, so we are going to do this next problem solely using the calculator. But I have to show you how to do it like this when we get to the next problem, though. But for now, I'm going to show you where to go on your calculator to end up doing this. All right, everyone, if you have the updated operating system, which it seems like most of you guys do, you can go to Alpha Window. Everyone go to Alpha Window right now, and you'll see our buddy, right? Everyone see him? Number 2, Alpha Window. All right, most of us, Alpha Window 2. Look at that. You just got to plug in for it. So in this case right here, help me out. What's my starting value right now? K equals 3. So if you want to use the K button, find out where K is. You could also just plug in X instead if you want, if that's easier for you to find. Okay, so K, see right here, equals 3. And what's my ending value? Oh, I got to plug in 3, sorry. What's my ending value? 5. There you go. Now here's the catch, though, if you want to use it, and this is specifically why I picked this problem. Do you see I need to plug in K squared plus K? But it's got to go in this entire parenthesis that was given. Don't put anything on the outside. Okay? So here we go. Ready? K, or if you used X, K squared plus K. Everything, the entire function has to go in that given set of parentheses. And then, hey, 62, we're done. Okay, 62. Why didn't he tell me this before? Making me go through all this misery. There's a reason behind it, trust me, and it's on the next problem. All right, if all you could do was just use your calculator, I would have shown you from the beginning, but that's not the case. Are we all good here? Okay, well, why did I show you to do it by hand instead of just showing you the calculator right from the get-go? And here is why. Your calculator is only good for one variable in the function. When you get a problem that's got 2, it's no use to you. Okay? So again, all these problems we just did, numbers 1 through 4, does everyone see how there was only one variable in the function? Okay, go ahead, use your calculator. Fine, I'm never going to stop you. But when there's 2 variables, we got issues. Your calculator does you no good. But you already know how to do it. All right, we've been doing them by hand all class. So let's just do this one. What's this 4 telling me to do at the end? Add 4 to your sum. So ready? What number am I starting out with? 2. So 3 times 2. Did it say to plug in for X? No, leave it X. Done. Now plug in what number? I just plugged in 2, plug in. Well, what's this going to give me, first of all? 6 minus 3x. Just remember, bring down that 4. So 4 plus 6 minus 3x. All right, what number do you want to plug in next? We just plugged in 2. Now plug in 3. Go ahead. So 3 times 3 minus x. And you end up with 9 minus 3x. And again, what am I doing to every term here as I go along? Adding them together. That's what the sigma tells me. So now plug in what number? We're almost there. 3 times 4 minus x. So that'll give me 12 minus 3x. Keep going, or are we done? Question, Austin? Which one? Here? Okay, I started by plugging in 2 for k. Now I plug in 3 for k. Now I plug in 4 for k. Remember, the only variable I'm plugging in for is k here. Everyone else all right? And then I plug in 5 for k. And I end up with 15 minus 3x. Add them up as you go along. Combine your like terms now. Let me know what you end up with. After combining all your like terms, you end up with, who's got 17? Okay. 15? There we go. Choice number 4. Okay, do you see how these sigmas work now? Okay, see how they work? I'm going to skip over the next 2 because I do have to get to something else before you leave today. Do we understand how it works? Again, hey, if it's one variable in the function, go ahead, use your calculator. I don't care. I expect you to. All right, make your life easy. But if it's got 2 variables, a little bit different if it's got 2 variables. All right, so you've seen that you can add something that's not arithmetic. But what if it is arithmetic and there's no sigma attached to it? Okay, so take a look at number 8 for me. Let's start adding up an arithmetic series now. So the sequence is arithmetic, and I want to add it up. There's no sigma involved now. I got to do it on my own. All right? So find the sum of 12 plus 19 plus 26, ... all the way up to 180. Am I expecting you to find the pattern and do that all in your calculator? Absolutely not. All right, we have a formula that will do it for us. Everyone have their formula sheets out? This is the only formula you are not going to be given. So you are responsible for, all right, on your formula sheet. And it is the following. Ready? S, capital S, what do you think that stands for? Sum. Yep. Subscript N. So the sum of a certain amount of terms is equal to the amount of terms we're adding up times A1 plus A subscript N, all divided by 2. And I will help you fill this in right now. That is not on the formula sheet. I will give you a fresh formula sheet Friday. Okay, that is the only one this unit you are responsible for. Okay. Okay, so help me fill it out. Can you fill out what the first term is? First term is 12. Okay. So 12 plus, this will usually be the last term in the sequence that we're adding, which is 180 over 2. This is going to be how many terms we're adding up. Ooh, 1, 2, 3, a bunch in the middle, and 180. I don't know how many terms we're adding up. Is there anything else we have already used pretty recently that tells us how many terms we have? Anything we've used? Remember, what's the only other formula you have for arithmetic? The explicit formula on your formula sheet, which says what? A sub n equals A sub 1 times n minus 1 times d. This will tell us how many terms we're adding up. Here we go. What was the last term? I want to know. 180 is the what term of this sequence. That'll tell me how many terms I'm adding up. What was the first term? 12 plus, I'm trying to figure out what term 180 is. Do we see why? I'm trying to figure out what term 180 is so I know how many total terms I'm adding up. And what's the D value here? Common difference. Austin? 7. I'm adding 7 every time. So 180, you can do it with me here, plus 7n minus 7. (180 equals 7n). What's that? Plus 5. So go ahead, finish that up for me. What term is 180? It's the what term? 25th term, right? Which means how many total terms do I have? 25 terms, yep. Okay, 25 terms. And if you wanted to put it over here, this means you're finding the sum of 25 terms. So if you did add all of them up together, go ahead. What do we end up with? All those terms add up to? Austin, what do you got? Yep, 2,400. So I didn't know how many terms I was adding up, so I looked at my explicit formula, filled in everything, and solved for n. Let's see if I can get through this next one without the bell cutting me off, maybe. Find the sum, all right, sum. So there's my formula I just given you that you're responsible for. What's my n value now? It's given. It is. So the sum of 16 terms is equal to, n value again was what? Times first term. Whoa, was that given? First term given? No, but do you have a formula that can find the first term? My explicit formula. So I'm going to plug in for everything except for a subscript 1. So give me a sub n here. 240 equals first term plus, what's my n value again? 16 minus 1. And then what's the d value also given? 8. Solve for the first term. Solve for the first term. And I'll just let you know, because we're running out of time, first term ends up being 120. Plug that in, plus the rest of the problem, 240 over 2. You guys got it. Good job today. Try out some of the problems. Bring all your questions tomorrow.